All right, so in this video, we're going to do, this is a summary of our 0.2 on solving equations, inequalities, and absolute values. Okay, so let's start back kind of at the beginning, the very basic equation solving. We have something like 3x minus 10 equals 11. We're trying to get x by itself. So we're trying to get back to what it was before we multiplied and subtracted 10. Okay? So what we want to do is work backwards. Now, if you think about it, order of operations, we would have taken the x and multiplied by 3 first and then subtracted the 10. So to get back to the answer, we're going to go backwards through the problem, and we need to get rid of the 10 first. Don't really know why I'm doing the equals, don't really need that there. I'm going to add 10. Not 20, not 2, not 12, 10. Now, what does that leave us with? 3x and 21. And now the opposite of multiplication is division, so we're going to divide by 3, and that gives me x is 7. And again, as we've talked about before, the beauty of algebra is you can plug that back in real quickly in your head. 3 times 7 is 21, minus 10 is 11, check. All right? Now, we could have a very similar problem, except x over 3 divided by 3 minus 10 equals 11. Well, still, according to PEMDAS, order of operations, this would still be done first, and this would be done second. Therefore, we're going to get rid of the 10 first, working backwards. But this time, I'm left with x over 3 equals 21, which means I need to multiply to undo the division. X equals 63, which if I plug that back in, divide 63 by 3, get 21, subtract 10, boom, I've got 11, and I'm good to go. Now, let's step it up a little bit and do something like this. 6 times x minus 2 equals 18. Well, in this case, there's actually two ways to approach this problem. I'm going to show you both. I know my personal favorite way, but everybody has their own way of approaching things. You can distribute this, and sometimes you have to. Okay, if that was a 5, we'd have to do this problem this way. All right? But there is an option, and we'll get to that. But I'm going to multiply and get 6x minus 12 equals 18. Again, I'm going to work my way backwards, add 12 to both sides. That gives me 6x equals 30. And then when I divide by 6, I get 5, which if I plug back in, 30 minus 12 is 18. But since 6 is a factor of 18, I can actually divide first without distributing and have x minus 2 equals 3. And then I just have a simple one-step equation, and there's my answer, 5. Same answer. Okay? To me, just a little less work. Because here, you took the 6 and sent it through, but then you divided by it. So you created a little bit more work for yourself. But like I said, if that would have been 5 outside, that would not have worked because you'd have to divide, you'd have to multiply because 5 does not go into 18. All right? And it would have been a mess. Okay, let's get it a little bit more complicated here. 2 times 3x minus 10 plus 4 equals negative 4. Okay, more going on here. We need to get to the x. Right now, the x is in parentheses, and it has this 2 kind of standing guard outside. So we need to get rid of this first, which gives me negative 8. And this doesn't change. Now, some people at this point, when they wrote it, might just multiply and put 6x minus 20 first. It's up to you, whatever works for your brain. But in this case, again, we have the choice of sending the 2 in, or since 2 does go into -8, we could just divide by -2. It makes no difference. Okay, I'm not going to show both ways this time. I'm just going to get rid of the 2 this time. But again, if you got 6x minus 20 equals -8, you'd be fine. You'd add 10 and divide by 6. But in this case, I've got 3x minus 10 equals -4. Now I'm back to a simple two-step equation. Add 10 here. 3x equals 6. Divide by 3. And my answer is x equals 2. Which if I plugged it back in, I'd get the same answer. Okay? All right, let's step it up a little bit more with some stuff on both sides, like so. -1 plus 8x equals 3x plus 6x. Now this has two things on both sides, but really this can just be simplified. So this is really -1 plus 8x equals 9x. Well, in this case, I want my numbers on one side and letters on the other. A lot of people feel like they have to have the numbers on the left side, and that's fine. You'd create more work for yourself and a negative value, but it's up to you. But I'm going to go the simplest route and just get my x's over here, since I already have that number -1 over there. And that's going to give me 9x minus 8x is 1x, and I'm done. X equals -1. Now, what about something like this with truly two different things on both sides? Number and a letter equals a number and a letter. You have to choose. You can get the x's on the left side or the right side. It makes no difference. You'll get the same answer. And if you want to fast forward through this, I will show it both ways. So, if I decided that I wanted to get my x's on the left side, I would do this. I want this over here, so I have to subtract x. That's going to give me 4x plus 2 equals 12. Well, if the letters are on the left side, this 2 has to go over here by subtraction. And that gives me 4x equals 10. Hopefully you're screaming at the screen saying you made a mistake, because I did. And this is the beauty of this. I've been doing this forever. All of us have. We know what we're doing. We know math. But guess what? We're also human and we make mistakes. And you're going to make mistakes too. And it's okay to make mistakes. That's why we check things. And if I would have checked this when I was done, I realized I made a mistake. But I just caught it now because I kind of knew where I was going. 3 minus 1 is not 4. 3 minus 1 is 2. And now when I divide by 2, x equals 5. And if I plug that in here and here, I would get the same answer, 17 on both sides. 3 times 5 is 15 plus 2 is 17. 12 plus 5 is 17. And everything works out fine. Again, I could have also gone this way. Let's say I wanted my letters on the right side. That's okay. I would subtract 3x here, subtract 3x here. The only difference is I'm going to end up with, not two equal signs, I'm going to end up with -2x. But over here, I'm going to end up with -10. So when I divide by -2, I'm going to end up with still x equals 5, because a negative divided by negative is positive. So there's not one right way to do it. It's whatever you're comfortable with and feel best about. Okay? Now let's step it up a little bit and do something like this. -6 times x minus 3 equals 17 minus 6x. Okay? Well, I have to distribute here. Nothing else to do because I have too much on the right side. Negative 6x plus 18 equals 17 minus 6x. Well, I want to move the letters over. So I'm going to add 6x. But look what happens. All my variables cancel out, and I end up with this statement. 18 equals 17. Okay? Well, that is not a true statement. That is a lie. 18 is not equal to 17. And if you end up with a lie, a non-truth, that means there is no solution. There is no number in the universe I could plug in for x here and get a true statement. Because as you can see, 18 does not equal 17. Okay? So if you ever end up with a false statement, it is no solution. Now how about this one? 3x plus x minus 4 equals negative 4 plus 4x. Okay? Well, first thing I want to do is always simplify. So I have 4x minus 4 equals negative 4 plus 4x. Some of you may already see where this is going. Some of you might see that this and this are the same thing, just in a different order. I could rewrite this as 4x minus 4 also, which means already I could stop the problem. I'm already done because if the two sides are equal, that's a true statement and I know the answer. But let's go a little bit further. Plus 4 plus 4. That gives me 4x equals 4x. Again, a true statement. I could stop if I wanted to. I could go further though and divide by 4 and get x equals x. Again, a true statement. Or up here, if I would have instead gotten rid of this first, I would end up with the statement negative 4 equals negative 4. And no matter what, true statement, true statement, true statement, even up here, true statement. If I end up with a true statement, my answer is all real numbers. Sometimes signified by this funky R with the extra line in front of it. Okay, that means I could put any number in existence in for x in the original problem, and I would end up with a true statement. All right, so that's it on equation solving. Now let's look at absolute value. That's when you have those absolute value bars. Okay, let's look at x plus 2, absolute value of x plus 2 equals 8. Now, what this is saying is, whatever this is 8 steps away from 0 on the number line. Okay, x plus 2 equals 8. All right. So most people will look at this and go, oh, I know what one of the numbers is, 6, because 6 plus 2 is 8. The absolute value of 8 is 8. We're good to go. I know the answer is 6. But then what's the other answer? Because absolute values could be right of 0 and left of 0. That means there's two answers possible here. Therefore, some people go, oh, well, it's negative 6. Well, if we plug negative 6 in here, we get negative 4. That doesn't work. So it's not that simple as just finding one and making it the opposite. So we have a procedure for this. We need to do this problem twice. But when we do it the second time, we have to make this number negative. So when I subtract 2 here, I get 6. When I subtract 2 here, I get negative 10. But if I put negative 10 in here, what do I get? Negative 8, and the absolute value of 8 is 8. So those are my two answers for the absolute value problem. Okay, so let's try something like this. Won't spend a lot of time in these because it's a pretty simple procedure. X minus 7 equals 13. Again, you just write the x minus 7, twice. You write the equals, you write the equals, you write the 13, but this time you make this negative. So now when I add 7, I get 20. Plug it in. 20 minus 7 is 13. Absolute value is 13. Add 7 here. That technical issues. Well, in this case, I get x equals 7 minus 13, negative 6. That's my other answer. And again, if I plug that in, negative 6 minus 7 is negative 13, but the absolute value of that is positive 13. Okay, those are pretty basic. Let's step up the difficulty. What if we had the absolute value of just the variable, but then we have something outside like so? Well, we can't do the break off of two problems until the absolute value is by itself. Therefore, we need to move this over first. Okay, and now that we have it alone, we can do our branching off and do x equals 14, x equals negative 14, and actually we're already done. There's nothing more to do. So what's the next level of difficulty? Let's put something out in front of, whoops, it's very easy to accidentally draw parentheses. We do those more often. Do something like this, and a number here equal to 11. Okay, well, again, we need to get the absolute value alone. Just like if it was 3x plus 2 equals 11. We'd still want to get the x alone by subtracting 2 divided by 3. Same thing here. We're going to subtract 2. The only difference is we got to remember to keep those bars until the very end. Divide by 3, just like we would here. Again, keep the absolute value bars. Don't get in the habit of just saying, oh, x is 3, because we still have to do the branching here. But it's really easy, because it's just x is 3 and x equals negative 3. Because remember, we just write this once, write it twice, write the equal sign, write the 3 twice, and make the second one negative. And that's it. Nothing too complicated there. Okay, here's the most complicated one so far. 3, absolute value, x minus 5, plus 2 equals 14. Well, again, we want to get rid of this first. Keep the bars. Oh, also, these are absolute value bars, not parentheses. We cannot distribute and say the absolute value of 3x minus 15. Very common mistake. Divide by 3. We're good to go. Just like the last problem. Very similar. X minus 5 in the bars still equals 4. Now we branch off. X minus 5 equals 4. X minus 5 equals negative 4. And then it's just a one-step equation. Add 5. Cancel. We get x equals 9. Add 5. We get x equals 1. Okay, inequalities. Inequalities are these symbols here. Generally, reading left to right, we say that's greater than, less than, greater than or equal, or less than or equal. But it really depends on which way we're reading it. I could say 5 is greater than 2, but I could also say 2 is less than 5. It just depends on the direction. Okay? But the mouth is always eating the bigger number. Okay? Remember it that way. The mouth, the, the fish, the piranha, the Pac-Man. No teeth on that one. But the mouth is always eating the bigger number. Okay, so let's get into inequalities, solving them, okay? Very similar to what we've done with equations. In fact, it's almost exactly the same. The only difference is there's one extra step in special circumstances, okay? So let's say I just had six times x minus 2 less than 18. Okay. Now again, I have a choice here. I could distribute the 6 or divide the 6 right off the bat and save a step. I'm going to distribute it this time. That's okay. 6x minus 12 is less than 18. Add 12. Add 12. 6x less than 30. Okay. Divide by 6. X is less than 5. That's my answer. I was going to put that on a number line. Here's 0, here's 5. Remember, we use open dots for less than. Let's go back over the top here. We use open dot, close dot, close dot. So this would simply be less than 5. All the numbers less than 5 work. Anything I put in there would work if it's less than 5. I could not put 5 in because that would give me 18 is less than 18, and that's not true. But if I went back and made this symbol, I would simply make it this filled in circle, and now it would be true. Okay, just remember that. All right, let's go with one more. Here it is, already written. So similar to previous problems, I want to get x by itself, but it's in parentheses and it has a guard outside the parentheses. So we're going to get rid of the 1 first. Now pay attention, those are two negatives. I'm subtracting 1 from 131. So that's going to give me negative 132. Some people going from here to here might distribute the 6 through right away. That's up to you. 30x plus 48 less than negative 132. I'm going to subtract 48 from both sides. And that's going to give me 30x is less than negative 160. Or 180, let's go with that one. That sounds better. And then we divide by 30. We get x is less than negative 6. And again, I could plug that in here and check it, and it would work out. It would be a number less than negative 131. All right? Now, let's do a simple problem. Well, what looks simple, but can be difficult depending on how you solve it. 4 minus 4x. As I've said earlier, it doesn't really matter where you have your numbers and your letters. But when you're dealing with inequalities, it can. Okay? Again, I can do this problem two different ways, and I'm actually going to here. X minus 6 greater than or equal to 4 minus 4x. And x minus 6 greater than or equal to 4 minus 4x. Let's say I want to move these over here. My x is on the left side. Well, what it's going to do is give me 5x minus 6 greater than or equal to 4. I'm going to add 6 and get 5x is greater than or equal to 10. And then when I divide by 5, I get x is greater than or equal to 2. Sounds good? If I plug it in and check it, I should get the correct answer, of which that is the correct answer. Now let's do this one. Let's say instead I want my numbers on this side. Okay, I would minus 4. That would give me x minus 10 greater than or equal to negative 4x. Which means now I need my x's on the right side. And I get negative 10 is greater than or equal to negative 5x. Well, notice right now my 5x, negative 5x, is on the less than side. Over here, my 5x was on the greater than side. But I also have those pesky negatives in there. Whoops. So let's do my thing where I divide by -5, divide by -5. Oh, that's good. X less than or equal to 5. I'm sorry, 2. Wait a minute. I have two different answers. This is another way of writing the same thing. Why on the left side did I get greater than? On the left side, on the right side, I got less than. Well, that's because I made a mistake somewhere. And I made it on this side here. Because there's a very special rule that we learned about with inequalities. If you multiply or divide by a negative number, you must flip the symbol. So this symbol here gets flipped like so. Very common mistake. So this is one case where, yes, you can do it either way, but if you solve for your variable to be on either side but positive, you avoid that situation with that rule. Just something to consider. Okay, let's look at this one. -6, x minus 3, greater than 17 minus 6x. All right, I'm going to distribute. -6x, positive 18, 17 minus 6x. Now, do I have to flip the symbol because I multiplied a negative number? No, because I only did it on one side. It's only when you're solving and you multiply and divide both sides by a negative, you have to flip the symbol. So we're okay here. Now, move my variable. I don't want negative, so I just talked about that. So I'm going to do this. Well, look what happens. 18 is greater than 17. Well, just like the equations, that's a true statement. So my answer is, and therefore the answer is all real numbers. Now, let's go back and change the problem. Let's say it was originally less than. Then I would have ended up with 18 is less than 17. That's a false statement, and that would have been no solution. Okay, so you got to pay attention to whether it's a true or false statement to know if it's all numbers or no numbers that work for that. Now, lastly, we're going to have numbers, inequalities that are compound. So there's more than one going on. So let's say we got -10 less than 2x plus 6 less than 16. Well, instead of solving in two places, we're really solving three. So whatever we do to one, we must do to all three. So when we subtract 6 here, we have to do it in all three spots. So it's going to give us -16. This stays. This stays, 2x. This stays, and this is 10. Now, if this was a -2x, as soon as I divided by -2, I would have to flip these symbols. But I'm not, because it's a positive 2x. So this is -8, x, and 5. And that's my answer. X has got to be less than 5, but greater than -8. So I'm looking on the number line. Here's 0. Here's -8. Here's 5. It has to be less than 5, but greater than -8, basically in between those two numbers, not including them. Now, what if we have something like this? X minus 6 is greater than 7, or x plus 4 is greater than 10. Well, we just solve them separately. X is greater than 13 when I add 6 to both sides, or when I subtract 4, x is greater than 6. So if I look at that on a number line, here's my 0, here's my 6, here's my 13. This says greater than 6. This says greater than 13. So if you think about it in this case, well, this arrow is really included in the x is greater than 6. So x is greater than 6 covers both. So that's our answer. And then along the same lines, similar to that, we're going to do this. 2x minus 9 greater than 11 and x minus 2 less than 1. So I'm going to do these separate again, just like I did before. 2x is greater than 20, which means x is greater than 10. So x is greater than 10. Over here, I'm going to add 2 to both sides. X is less than 3. Okay, x is less than 3. But this is the key thing here. This is an and statement. They're going opposite directions. There is no number that is less than 3 and greater than 10. Therefore, we have no solution. And that wraps it up.